Somewhere, 1,400 light-years away, a pale world orbits a sun much like our own. It lies within the faint, golden band astronomers call the habitable zone, that fragile distance where water may flow and life may begin to dream. Kepler-452b, Earth's older, larger cousin, bathed in soft light from a star nearing middle age. Tonight, we drift toward that world through time and silence, following photons that began their journey before we learned to write. Could this planet, so eerily familiar, be the mirror of our own destiny, or a warning written in starlight? Like and subscribe if you enjoy these journeys through the cosmos, and gently float with us beyond the edge of knowing. Let's begin. In 2015, the Kepler Space Telescope caught a whisper of light that dimmed every 385 days. A heartbeat from another world. That subtle flicker revealed a planet almost twice Earth's size, circling a star strikingly similar to our Sun. Each dip in brightness told scientists a story written in photons older than memory. It was an almost imperceptible change, a dimming so small that no human eye could ever notice it. Yet, across 1,400 light-years of emptiness, that flicker was enough to reveal the presence of something extraordinary. A world orbiting another sun, following its path with serene precision. Every orbit cast a faint shadow across the star's light, a cosmic wink repeating itself once every Earth year. To astronomers, it was not just a number on a graph. It was a pulse, the rhythm of a distant planet breathing in the light of its parent star. The Kepler mission had spent years staring into one small patch of sky, a region no larger than a clenched fist held up to the night. Within that narrow field, thousands of stars glittered in patient silence. Each one held the potential for discovery, yet most remained constant, unwavering. And then, from one point of light, catalogued as Kepler-452, came the softest whisper of change. For the first time, scientists watched its brightness fall by less than 1%, then rise again in perfect symmetry. It was the unmistakable signature of a planet passing in front of its star. For weeks, the data was checked, rechecked, and checked again. Could it have been an error? A flaw in the sensor? A random fluctuation? But the pattern returned, precise, periodic, and patient. The odds of it being a false signal were smaller than chance itself. Kepler had found a world. To the astronomers studying those curves of light, the discovery felt deeply intimate. They were looking at something no human had ever seen, not through a telescope, but through time itself. The light that carried the signal had left that star long before the Wright brothers built their first plane, before the telephone, before even electricity lit our cities. It had traveled through centuries of darkness, carrying the quiet testimony of another Earth-like planet. In that faint echo, humanity glimpsed itself, small, searching, and full of wonder. It wasn't just a discovery of astronomy, it was an expansion of perspective. For all of history, Earth had been our only known home. Now, that certainty began to shift. Somewhere, on a world 60% larger, gravity pulled oceans, winds carved landscapes, and a sun rose and set just as ours did here. As the data spread through the scientific community, something changed. Researchers spoke softly, almost reverently, about Kepler-452b, not as an object, but as a possibility. It reminded us that we are part of a living cosmos, one that still keeps its secrets just beyond the reach of our understanding. That single flicker of light, 0.01% in brightness, was enough to bridge 1,400 light-years of distance and billions of years of curiosity. A heartbeat pulsing across the universe, reminding us that even in the vast silence of space, something is always moving, always orbiting, always alive. Kepler-452 star is 6 billion years old, 1.5 billion years senior to ours. It burns a little brighter, a little hotter, a glimpse of our sun's future, Studying it is like peering forward in time, watching the slow aging of our own daylight. Every star tells a story of time, of hydrogen turned into helium, of slow fusion and patient light. Kepler-452, nestled in the constellation Cygnus, is a G-type main sequence star, nearly indistinguishable from our Sun to the naked eye. But hidden within its light is the quiet difference that comes with age. Its fusion fires burn just slightly faster, its warmth stretches a little farther, and its color has softened from pure white to a faint golden hue. It is, in every sense, our Sun as it will one day become. To look at Kepler-452 is to look into our own future, not through prophecy, but through physics. Our Sun too will grow older, its fuel slowly converting into heavier elements, its brightness increasing as hydrogen in its core becomes scarce. In a few billion years, Earth will find itself where Kepler-452b is now gently, inexorably warming beneath a more luminous star. Oceans will retreat, clouds will thin, the blue of our skies will pale to silver. Studying this distant system is like watching the next act of our planet's story, already written in the stars. For scientists, Kepler-452 offers more than curiosity. It's a living laboratory for understanding stellar evolution. Through telescopes, astronomers break apart its light, scattering it into a rainbow of data. Within those spectral lines lie secrets of temperature, composition, and age. Each tiny dip and flare of color marks an element in motion: hydrogen, helium, calcium, the building blocks of suns and worlds alike. The patterns match our suns almost perfectly, except for the subtle fingerprints of time. More metals, less hydrogen, more maturity. Imagine standing on a world orbiting that older star. Days would glow with a slightly warmer hue, light soft as honey, skies tinted deeper amber at dawn and dusk. It would feel like perpetual late summer, a world bathed in the calm radiance of a star past its prime. Plants, if they existed, would adapt, their pigments evolving to absorb slightly different wavelengths. Life would have learned patience under that aging glow. But there's something bittersweet in that light. For every extra billion years of age, a star gives a reminder of impermanence. Kepler-452's warmth is both life-giving and foretelling. It's the gentle whisper of entropy, the soft ticking of the universe's clock. Our own sun will one day follow, swelling and fading, its brilliance marking both creation and conclusion. And yet, in that slow aging lies beauty. The universe is proof that time itself creates harmony. Kepler-452 shines not as a warning, but as a reflection. It tells us that even stars grow old with grace, that even the brightest fires mellow with time. Watching it is like holding a mirror to our cosmic destiny, and finding, in the light of another sun, the quiet reassurance that growing older is simply another form of shining. Orbiting at nearly the same distance Earth keeps from the Sun, Kepler-452b receives just the right amount of warmth, a cosmic coincidence so perfect it feels intentional. Scientists call it the Goldilocks distance, where worlds can cradle oceans instead of ice or fire. It's one of the most delicate balances in the universe, the thin, invisible boundary between too hot and too cold. Venture a little closer to the star, and oceans boil into vapor, leaving behind a scorched, airless desert. Drift too far, and those same oceans freeze into unyielding ice, locking any hope of life beneath silent glaciers. But Kepler-452b orbits in that narrow middle ground, that slender thread of comfort where liquid water could exist freely. It's the same precious equilibrium that makes Earth possible, replicated across light years of emptiness. Astronomers call this region the habitable zone, but the term doesn't quite capture its poetry. It's less a zone and more a sanctuary, a region of warmth and shadow sculpted by gravity, chemistry, and chance. For Kepler-452b, that distance is about 110 million miles, almost identical to Earth's orbit. It circles its sun in 385 days, a longer year, but one still measured by familiar rhythms. Day and night, dawn and dusk, the turning of a world under a golden star, all would unfold much like home. From that vantage, the sky would look both known and strange. The star would hang slightly larger and brighter than our sun, its light painting the landscape in richer tones. If oceans shimmered there, they would reflect that light like molten glass, their waves whispering the same elemental language of hydrogen and oxygen. Mountains, if they existed, would cast longer shadows. Winds would rise with similar grace. Even the temperature range, perhaps between 10 and 30 degrees Celsius, would feel almost comfortingly Earth-like. It's this sense of familiarity that makes Kepler-452b so haunting. It's not a gas giant wrapped in storms, nor a frozen moon wandering the dark. It's a place that could feel like home, yet stands impossibly far away. 1,400 light-years beyond reach. Every time its star's light dips, astronomers see a mirror of our own world blinking across space. It's a reminder that Earth is not unique, that nature repeats her designs across the galaxy. But there's something quietly humbling in that repetition. It tells us that what we are, oceans, air, sunlight, life, is not rare but natural. The universe has made this combination before, and perhaps will again. Somewhere, beneath that distant star, there might be rain falling on soil, waves breaking on shorelines, or winds carrying the scent of alien oceans. The familiar distance of Kepler-452b isn't just about numbers or orbital mechanics. It's a cosmic echo, proof that the conditions for life are not isolated miracles, but part of a repeating pattern written into the structure of space itself. In that golden distance lies hope, that for every world growing old and dim, another waits quietly in the warmth. With a mass estimated 5 times that of Earth, Kepler-452b's gravity would press you down with quiet strength. Each step would feel heavier, each breath slightly slower, a gentle reminder that even familiar worlds carry alien weight. On a world like this, gravity would feel almost personal, a constant presence, unseen yet undeniable, guiding every motion and thought. If you were to stand upon its surface, your body would immediately know you were elsewhere. Muscles would ache a little more. Your heartbeat would thrum with measured effort. Even the air, if breathable, would seem thicker, clinging to you like a warm ocean. Kepler-452b's gravity is about 1.9 times stronger than Earth's, enough to make each gesture deliberate, each movement profound. Yet, that same heaviness would bring stability. Oceans would lie deeper in their basins, held tightly by the planet's pull. Mountains would rise more cautiously, their slopes softened by the immense weight of their own stone. Rivers would carve their paths slowly, and the atmosphere, denser and more enduring, would wrap the world in an embrace that resists the loss of air to space. On Earth, gravity balances our fragility. On Kepler-452b, it defines endurance. If life exists there, it has adapted to this constant pull. Trees, if they exist, might grow shorter and sturdier, their trunks thick and knotted to withstand the downward tug. Wings, if anything dared to fly, would be wide and powerful, beating slowly against the heavier air. Creatures might crawl close to the ground, built not for speed but for strength. Even oceans, restless as they are, would move differently, waves shorter, their crests falling with quiet grace. For scientists, that added gravity isn't just a curiosity, it's a key to understanding what kind of world Kepler-452b might truly be. A planet 5 times Earth's mass likely holds a dense, rocky core, surrounded by silicate mantle and perhaps capped with vast, pressurized oceans. That means more heat trapped within, more tectonic energy, and a longer-lived magnetic field, one that could shield its atmosphere from stellar radiation. Paradoxically, the planet's very heaviness may make it more habitable, not less. But gravity also shapes perception. Imagine standing on that world at twilight. The horizon would curve more tightly beneath you, the sky stretching wider and heavier. The air might glow in deeper shades of amber and blue, scattering light through a thicker blanket of gases. You would feel grounded in the truest sense, connected, anchored, humbled. The gravity of Kepler-452b reminds us that weight is not only a physical force, but an emotional one. It teaches that beauty can be measured not just in lightness or flight, but in the quiet strength of what endures. In its pull lies a kind of grace, the steady rhythm of a world built to last. And perhaps, somewhere beneath that heavier sky, life has already learned the same lesson, that to thrive is to adapt, to grow strong beneath pressure, and to find peace in the gravity that holds you home. We've never seen its clouds, yet computer models paint them in whispers of blue and pearl. Perhaps it holds a sky rich in water vapor, or a greenhouse of carbon dioxide, dense and golden. Somewhere between those possibilities, life could stir. The truth is, every image we hold of Kepler-452b's sky is a dream built on equations. Light curves, mass estimates, and orbital distance sketch the faintest outlines of what could be. The pressure of air, the thickness of clouds, the shimmer of gases swirling above unseen continents. It's an atmosphere that exists for now only in mathematics and imagination, a portrait painted with physics instead of pigment. If Kepler-452b is truly Earth's older cousin, then its sky may have changed with age. Billions of years of sunlight would have slowly warmed the planet, evaporating oceans and thickening the air. What began as a cool blue atmosphere might now be dense with carbon dioxide, shimmering with the haze of a world entering its long, slow summer. From orbit, it could gleam softly, its color deepened by time, a sapphire world fading toward gold. Imagine standing beneath that alien sky. The light would feel familiar at first, bright, warm, comforting, but linger longer on the skin, like afternoon heat that never fully fades. Clouds might tower higher than ours, their tops glowing amber where sunlight scatters through the heavier air. Thunder would sound slower, deeper, as if the very sky had weight. Rain, if it falls, might descend in warm sheets that cling to the surface before vanishing in mist. If the atmosphere is rich in water vapor, it could nurture thick blankets of cloud, reflecting sunlight and keeping surface temperatures stable, a natural thermostat. Such a world could still cradle oceans, hidden beneath veils of mist. But if the air has tipped toward carbon dioxide, it may be shifting into a runaway greenhouse where heat gathers and refuses to leave. In that scenario, seas would shrink to shallow basins, and the air would shimmer with the dry shimmer of a warming planet. Either version tells a story that mirrors our own, of balance and tipping points, of climate as both guardian and destroyer. The chemistry of an atmosphere determines not just temperature, but destiny. On Earth, a thin layer of gases shields us, feeds us, and remembers every breath ever taken. Kepler-452b's sky may have once done the same, carrying the collective exhalations of whatever life arose there, a planetary sigh now suspended in time. We may never see its clouds directly, but the telescopes of tomorrow will try. Spectrometers will catch the fingerprints of light passing through its air, tiny dips in color that reveal what gases swirl within. Each molecule will tell part of the story. Water for life, carbon for change, oxygen for something more. Until then, the atmosphere of Kepler-452b remains an act of imagination, a reminder that sometimes the most vivid discoveries are the ones we cannot see. In that unseen sky, there may linger the faintest echo of breath. A year on Kepler-452b lasts 385 Earth days. Seasons stretch longer, shadows move slower, and sunlight lingers as if reluctant to leave. Imagine standing beneath a sunset that lasts an entire week. On Earth, we measure time by the rhythm of our orbit, a balance between motion and gravity that gives us the familiar cadence of seasons. But on Kepler-452b, the dance is just a little slower. The planet moves around its star with patient grace, taking 20 extra days to complete the same circuit that Earth does in 365. That difference, though small, reshapes everything about how life might feel there. Days would be nearly the same length, but the passing of the year, the cycle of warmth and cold, growth and rest, would unfold like a stretched melody, drawn out and deliberate. Imagine what that would mean for a world beneath that older, brighter sun. A spring that lasts longer, giving life more time to bloom. Summers that drift lazily, heat settling in slowly like a sigh. Autumns lingering in endless twilight, leaves or alien equivalents holding their color for weeks before falling. Even winter, if it exists there, would feel patient, more reflection than retreat, as if the planet itself were reluctant to move on. Under that slower rhythm, everything might evolve differently. Plants, or whatever passes for them, could grow taller and stronger, nourished by the prolonged seasons of light. Creatures might migrate at different intervals, guided by the longer orbit. Weather patterns could stretch across continents, storms building over months, dissipating over seasons. Every process, from erosion to evolution, would be tuned to a softer, slower beat. And then there's the light, that golden, steady sunlight from Kepler-452's aging star. Because the planet's orbit is so stable and nearly circular, its seasons would not be extreme. The sunlight would wax and wane gently, its warmth constant, reliable. To the eye, that might make the world feel timeless, as though it existed in a permanent afternoon, where every hour glows softly, and shadows never truly grow cold. For any potential life there, this stability could be a blessing. Evolution thrives on consistency. A long, predictable year means ecosystems have time to adapt, to harmonize with the turning of the world. Life wouldn't need to rush. It could take its time to grow, to reproduce, to learn the rhythm of a world where patience is rewarded. And for us, looking across the distance, Kepler-452b's long year offers something poetic. It reminds us how deeply time is woven into perception. A single orbit there feels just slightly different from ours, yet across that small change, entire civilizations, if they existed, might have built calendars, rituals, and myths around the slow heartbeat of their sun. A year that lasts a little longer, a world that turns a little slower. It's a small thing, yet profound, proof that time itself is relative not only to motion, but to meaning. On Kepler-452b, the days would invite stillness, the years would whisper patience, and the sunsets would linger long enough to make you believe that perhaps, in some corner of the universe, even time takes its time. Some models suggest oceans once rippled across its surface, vast, deep seas under gentle suns. If they still exist, they could shimmer now beneath an amber sky, cradling forms of life, evolved in patient silence. Water is the great storyteller of worlds. Wherever it flows, it writes the language of change, carving valleys, shaping clouds, birthing the chemistry of life. On Earth, it was water that transformed dust into DNA, that turned a barren planet into a cradle of blue. So when scientists first modeled Kepler-452b, they wondered, did water ever grace its surface too? Given its distance from its star, nearly identical to Earth's, and the stable warmth of its orbit, it's entirely possible that Kepler-452b once had oceans. Early in its history, when its star burned slightly cooler, conditions could have been nearly perfect for liquid water to gather and persist. In the young days of that system, as volcanoes exhaled their gases and minerals mingled in the air, rains might have fallen for centuries, filling basins and craters until the planet wore a coat of shimmering seas. Imagine those ancient oceans, vast and slow-moving, tinted with faint green under the golden light of a slightly older sun. Waves might rise heavier, thicker, under stronger gravity, their crests glowing with soft reflections. The sound of such water, if there were an ear to hear it, would be lower, steadier, like the heartbeat of a planet breathing beneath its surface. But as Kepler-452's star aged, it began to brighten. The slow intensification of starlight would have warmed those oceans inch by inch over millions of years. If the planet's atmosphere was rich in greenhouse gases, that warmth could have trapped itself, amplifying the cycle, water vapor thickening the air, clouds building higher, rains growing heavier, until the world entered a slow, irreversible transformation. Oceans might have boiled away, leaving behind the ghostly scars of riverbeds and evaporated seas. Yet even in that imagined desolation, there's beauty. Because water never truly disappears, it changes form, hides in minerals, lingers in vapor, or freezes beneath the soil. Deep below Kepler-452b's surface, there may still be aquifers, pockets of ancient water preserved in darkness. If microbial life ever emerged there, it might have retreated underground, waiting out the planet's slow warming like embers under ash. In this way, Kepler-452b becomes a mirror of our own planet's potential fate, a world that may once have thrived in blue, now perhaps golden and dry. Its story might echo Earth's far future, when our own oceans will recede beneath a strengthening sun. But maybe, just maybe, some seas remain. Hidden beneath layers of haze, they could still reflect that aging light, their surfaces whispering of what once was. And if something stirs within them, it would be life adapted to time itself, ancient, patient, and wise in the ways of survival. To think of such oceans is to remember that life, once begun, is reluctant to end. The universe, too, remembers its waters, for in every drop there lies the potential for memory, reflection, and rebirth. If clouds rise and cool there, rain might fall in heavy, lingering drops, each one tracing the same chemistry that sculpted life here. Hydrogen, oxygen, carbon, the alphabet of existence written again across the cosmos. Rain is one of the most intimate acts of a living world. It connects the sky to the soil, the clouds to the sea, the atmosphere to the heartbeat of everything below. On Kepler-452b, that same gentle cycle may have once existed, or may still continue today, unseen, unrecorded, but eternal in rhythm. Imagine standing on that distant world as its older sun filters through a pale haze. The air would feel thick and warm, the scent of minerals and vapor mingling like the breath of a living planet. Above, clouds would gather, towering forms of water vapor, or perhaps ammonia and carbon compounds, their edges glowing amber where sunlight scatters through the dense atmosphere. And then, almost imperceptibly, the first drops would begin to fall. They would fall slower than rain on Earth, pulled by stronger gravity through the dense air, each droplet round and heavy like liquid glass. They might make a deeper sound when they struck the ground, a soft, resonant rhythm echoing through the planet's quiet air. Hydrogen and oxygen, ancient as stars themselves, mingling with carbon drawn from stone, creating the subtle patterns that mark the beginnings of life. Rain, after all, is not just weather, it's renewal. On Earth, it seeded the first oceans, nourished the first forests, shaped the first rivers. Every cycle of water carries memory. The evaporation of ancient seas, the condensation of new storms, the return of life to soil. On Kepler-452b, that same story could be written again, line by line, in droplets that fall like words from the sky. If the air is rich with water vapor, the planet's rain cycle might be intense but slow, long, steady storms that sweep across continents. Each deluge would feed the surface, filling basins, carving valleys, and perhaps gathering in vast inland seas. The cycle might move on a grander scale than ours, measured not in days but in seasons that last for months. Between rains, mist could hang in the air, softening the light, wrapping the world in quiet humidity. But if the greenhouse thickening of its star has already begun to take hold, that rain may now be rare, a relic of a cooler age. Clouds might still form, but release nothing. Droplets could evaporate before touching the ground, falling as phantom rain that returns to the sky. A planet remembering what it once was, dreaming of water even as it fades. Still, even the possibility of rain carries hope, because wherever water moves, life tends to follow. In that imagined downpour, in those unseen rivers and vapor trails, lies the same universal chemistry that once touched Earth. And so, when we imagine the reign of Kepler-452b, we aren't just picturing weather, we are picturing memory, renewal, and the enduring rhythm that ties every living world to the stars. Somewhere, perhaps, rain still falls there slowly, softly, beneath an amber sky. Kepler-452b's star has begun to brighten. Slowly, imperceptibly, the planet's climate may be changing, oceans retreating, skies thickening. To glimpse it now is to see our own far future Earth, warming under an aging sun. Change in the cosmos rarely happens in moments. It unfolds in millennia. The light of Kepler-452, now stronger than it once was, pours more energy into its companion world every passing century. What began as a gentle cradle of life could now be crossing a fragile threshold, that subtle boundary between balance and burn. It's a transition written not in years, but in the slow pulse of stellar evolution. Over billions of years, as hydrogen in the star's core fuses into helium, its luminosity gradually increases. For Kepler-452b, that extra sunlight means a slow but certain warming. Oceans that once shimmered beneath soft blue skies may now be retreating, not vanishing all at once, but shrinking at the edges, evaporating molecule by molecule. The air thickens as water vapor rises, trapping more heat, amplifying the cycle. It's a planetary feedback loop that Earth itself will one day know. Imagine that world now, its once temperate land stretching beneath a deeper, hazier sky. The sunlight that falls there is still beautiful, but heavier, infused with a golden sharpness. Clouds drift higher, broader, reflecting more of that growing brilliance. Rivers may have pulled back into narrow threads, winding through ancient basins where lakes once shimmered. In the distance, heat waves ripple like mirages, bending light as though the air itself were sighing. If life once flourished there, this slow transformation would be both challenge and teacher. Evolution on a warming planet becomes a race of adaptation, organisms shifting toward resilience, moving underground, into the shade, into the depths of what remains. Some may thrive on the edge of drought, learning to drink from the air. Others may vanish, their existence recorded only in the chemistry of the soil. The planet would not die all at once. It would age with dignity, like a world entering its long afternoon. This, scientists believe, is what awaits Earth too, in roughly 1 billion years. As our own sun brightens, our oceans will evaporate, our clouds will thicken, and our atmosphere will begin to trap more heat. Earth will transform from a blue world to a pale, arid one, not destroyed, but evolving into a new phase of existence. Kepler-452b may already be living that future. It's a haunting mirror, one planet, 1,400 light-years away, quietly showing us our tomorrow. It tells us that habitability is temporary, that even paradise is fleeting. Yet within that truth lies something peaceful. An understanding that everything, even worlds, follows a natural rhythm of birth, bloom, and decline. To gaze at Kepler-452b now is to see a planet mid-transformation, neither dead nor fully alive, a living memory of what was and a preview of what's to come. And perhaps that's the deeper beauty of it, not its perfection, but its impermanence. It reminds us that change, no matter how vast, is simply the universe continuing to breathe. Astronomers call it Earth 2, but it's more like Earth's reflection in a slightly older mirror. Everything looks familiar, until you realize time has gently shifted the frame. When scientists first studied Kepler-452b, the resemblance was uncanny. A rocky planet, orbiting a sun-like star, sitting in the habitable zone, the same comfortable region that makes life possible here. On paper, it was a twin, a second Earth suspended in the black. Headlines called it our older cousin, a poetic shorthand for the discovery of something hauntingly familiar. But as the details unfolded, the resemblance deepened and darkened. This was not another Earth, alive and young, This was what Earth might become after another billion years beneath a slowly brightening sun. It's the kind of discovery that stirs both wonder and unease. Because when we look at Kepler-452b, we are not just looking outward, we are looking forward. Its star, older and hotter, has likely pushed its climate toward change. What may have once been a lush, ocean-fed world could now be entering its long, reflective twilight. If oceans still exist, they might be smaller, saltier, clinging to the shadows of highlands. The atmosphere could be thicker, its air warmer, filled with shimmering haze that softens the sunlight into gold. Imagine standing there, the gravity heavier, the air denser, the sky tinted with the faint bronze of an aging star. The land beneath your feet feels steady, ancient, shaped by billions of years of wind and rain. You look to the horizon and see a sun just a touch larger than ours, its warmth not harsh, but insistent. The light has a quality of memory to it, as though every photon carries a story of ages past. It's a world that seems to remember everything that came before. And perhaps, once, something did live there. Maybe microscopic forms that thrived in the oceans before they grew warm. Maybe plant-like organisms that covered the surface in green before the heat began to rise. Perhaps even civilizations that watched their world change and wondered if the stars held others like them. Now, all that remains may be the traces, minerals rearranged by biology, gases lingering in the air, patterns carved into the land by rivers long gone, a pale echo of life, whispered in stone. This is why scientists are so fascinated by Kepler-452b. It is not only about discovering another habitable planet, it's about discovering a future, a version of our world written a billion years ahead, showing what time does even to paradise. For every habitable zone, there is a moment when balance begins to tip, when the line between Eden and extinction blurs. Kepler-452b reminds us that the conditions for life are delicate, but also universal. The same physics that nurtured Earth have likely nurtured countless others. The same chemistry that built us has built other dreams, but all of them are temporary, each shining for a while before fading into the quiet calm of age. So when we call it Earth 2, perhaps it's not a successor we're naming, but a reflection, a ghostly vision of home, caught mid-transition, reminding us that even in the grand stillness of space, nothing ever stays the same. Not stars, not worlds, not even us. We've never seen Kepler-452b directly. We know it only through the language of light, the faint dimming of a distant star, the tiny pulse that tells us a world is there. In that subtle change, less than 1% of brightness, the story of a planet unfolds. It is astonishing to think that all we know of Kepler-452b comes not from an image, not from a photograph or a shadow, but from the way light falters for a moment before returning. Every orbit, every crossing, creates a whisper in starlight, a rhythm written in the flicker of photons that began their journey long before humanity first looked up and wondered. The Kepler Space Telescope was built to listen for these whispers. Its detectors, unimaginably sensitive, measured the brightness of over 150,000 stars at once. Most remained steady, their light constant and pure. But every so often, a pattern emerged, a soft, periodic drop that could mean something had passed before the star. Not a moon, not a flare, but a planet, quietly tracing its path in front of the light that birthed it. From this dimming alone, astronomers can extract astonishing truths. The depth of the dip tells them the planet's size. The time between transits reveals its orbit, its year. The shape of the curve even hints at whether it's rocky or gaseous, hot or temperate, tilted or straight. It is the art of deduction at its most cosmic, reading the invisible through the faintest alteration of light. Kepler-452b's discovery came from such delicate mathematics. Each photon captured by the telescope was a messenger, carrying information across centuries of darkness. By decoding that message, scientists uncovered the shape of another Earth, an entire world reconstructed from the tiniest fluctuations of brightness. It's a reminder of how much can be known without ever being seen. If we could view the star through human eyes, the difference would be imperceptible. It would shine like any other, steady, unwavering. Yet, hidden within its radiance is the pulse of another world. Every time the planet passes, the star dims for about 10 hours, its light briefly softened by the passing shadow of its companion. It's as if the universe blinks, acknowledging its own complexity for just a moment. And beyond the data, beyond the science, there's something poetic in that dimming, that we find new worlds not through brightness, but through absence. That discovery can come not from what we see, but from what we almost miss. It's as though the cosmos is teaching us patience, urging us to notice the subtle changes, the tiny pauses that reveal hidden truths. Through light, we've learned to find what cannot be touched. Through light, we've mapped the orbits of unseen planets, the chemistry of invisible skies, the birth and death of stars. Light is our oldest messenger, our truest witness, carrying stories across unimaginable distances, waiting for someone, somewhere, to finally understand. And so we listen still, watching for the faintest flicker, the gentlest shadow, because somewhere, in that rhythm of dimming and return, another world is waiting to be known. Every data point from the Kepler telescope is a promise wrapped in uncertainty. Algorithms sift through millions of starlight curves, seeking that subtle rhythm of orbit, the quiet dance that means planet. At first glance, the data looks like nothing more than noise, a sea of numbers, brightness values rising and falling in patterns too faint for the human eye to follow. But hidden within that apparent chaos are the signatures of worlds. Each small dip in a star's light, each repetition across time, may represent a planet transiting its host, a brief, celestial alignment visible only through mathematics. The Kepler mission gathered an ocean of this information. For nearly a decade, it watched over 150,000 stars, taking a measurement every 30 minutes, night after night, year after year. In that flood of data, true signals were vanishingly rare. The challenge wasn't in collecting the light, it was in recognizing meaning within it. So scientists turned to algorithms, teaching computers to search for regularity, for rhythm, for that faint repetition that no human mind could hold in focus. When the first hints of Kepler-452b appeared, they came not as an image or a sound, but as a sequence of numbers on a screen. The star dimmed by just 0.2% every 385 days, a tiny but consistent pulse. It was elegant in its simplicity, brightness, then shadow, then brightness again. From that pattern, the entire story began to unfold. Mathematically, each planet's transit produces a curve, a soft dip like a heartbeat on a monitor. The depth of that dip reveals the planet's size, its duration tells of its orbit, and its timing confirms its reality. But the data is fragile. A single error in calibration, a cosmic ray, or the flicker of the spacecraft's motion can mimic a planet's passage. So, like detectives of the infinite, astronomers must test every signal, remove every bias, and confirm each possibility with patience measured in years. There's something quietly poetic about it, how math, the most abstract of languages, becomes the bridge between imagination and evidence. The Kepler scientists don't just look at light, they translate it. They take raw starlight and turn it into orbits, distances, and probabilities, transforming the intangible into knowledge. Behind every discovery, there's a tapestry of equations balancing gravity, geometry, and time, all working in harmony to reveal the invisible. And yet, even with such precision, discovery is never certain. Each candidate must survive scrutiny. The blending of models, cross-checking with other telescopes, comparing starlight in infrared, visible, and ultraviolet bands. Kepler-452b passed them all, earning its place not just as a number, but as a world. Still, uncertainty remains part of the beauty. Each calculation comes with margins, each orbit a probability. To explore the universe through mathematics is to embrace mystery and order in equal measure, to understand that truth often exists between the numbers, in the quiet rhythm of what almost fits. In that sense, discovery isn't a single moment of revelation. It's a long equation stretching across centuries, from Galileo's first observations to the modern algorithms that read starlight like music. Each new world is another note in the cosmic composition, a melody written in data, refined by logic, and played by the steady pulse of time. The mathematics of discovery reminds us that even in silence, the universe speaks. And sometimes, all it takes to hear it is the courage to measure the faintest change in the light. It's the celestial shoreline between ice and fire, a fragile band where temperatures allow liquid water to exist. Kepler-452b sits right within it, balanced on the edge of cosmic perfection. The term habitable zone might sound technical, but it's one of the most poetic ideas in astronomy. It is the cosmic sweet spot, not too close to the star, where oceans would boil away, and not too far where they would freeze into eternal glaciers. It's the distance where sunlight nurtures rather than destroys, where water can flow freely, and where chemistry has a chance to dream itself into life. Earth exists in this exact balance, and so, tantalizingly, does Kepler-452b. In the equations that govern stars and planets, this zone is defined by temperature, luminosity, and orbit. Around a hotter star, it lies farther out. Around a cooler one, it nestles close. Kepler-452b's parent star, slightly brighter and older than our Sun, extends this life-friendly region just far enough to include its orbit. For billions of years, it may have basked in warmth, perhaps nurturing oceans, rain. But habitability is not a constant, it's a moving frontier. As a star ages and grows more luminous, the habitable zone drifts outward like a tide of light. Worlds that were once perfect can slowly slide into heat, their oceans thinning, their skies growing heavy with vapor. Kepler-452b, positioned near the inner edge of that zone, may now be watching its paradise begin to wane. The same fate, billions of years from now, awaits Earth. Even so, there's wonder in the symmetry. Two worlds, separated by 1,400 light-years, orbiting suns so alike they could be reflections of one another, both suspended in that narrow, life-bearing corridor. It's as if the universe repeats its favorite melody, playing variations on the same cosmic theme. The laws that placed us here are the same laws that shaped Kepler-452b. In its orbit, we see evidence that life's conditions are not rare accidents, but natural harmonies of physics. If we could look upon it directly, the view might stir an ache of recognition. Its seas, if they still glisten, would reflect sunlight at the same angle ours do. Its clouds would drift in slow, swirling patterns, thick with vapor drawn from familiar chemistry. From space, it would look like a polished gem, a soft blue and white sphere turning gently in the light of its star. And somewhere, perhaps, under that light, chemistry might have taken its first, quiet breath. Maybe life began there long ago, in pools warmed by a stable sun, evolving through eons as its world aged around it. Or maybe it never did. Maybe the elements remained patient, the stage set but the actors never stepping forward. That's the haunting beauty of the habitable zone. It promises possibility, not certainty. Every world within it is a question mark, shimmering between what could be and what was never meant to be. And so, when we speak of Kepler-452b sitting in that fragile ring of perfection, we're really speaking about the balance that sustains us all. The narrow line where chaos becomes calm, where temperature becomes tenderness, where a planet learns to cradle life in its arms of light. The light there would feel almost the same as ours, warm, golden, familiar, but slightly brighter. Shadows would fall sharper, colors deeper, as though reality itself had turned up the contrast. Kepler-452's star is a near twin of our Sun, a G-type main sequence star, just a touch older, a fraction more luminous. To human eyes, its light would seem comforting, a homecoming glow cast across an alien horizon. But subtle differences change everything. Where our sunlight softens with youth, Kepler-452's carries the weight of age, richer in gold, tinged faintly with amber, like the final light of an endless afternoon. Standing beneath it would feel both familiar and strange, as if you were walking through a memory of home. Photons from that star would scatter differently through Kepler-452b's thicker air. If the atmosphere is rich in water vapor, the sky could be a deeper blue than Earth's, a velvet dome that darkens swiftly toward the zenith. If it's dense with carbon dioxide or other gases, the hue might shift toward greenish-grey or even copper, transforming dawn and dusk into prolonged, molten displays of color. Each sunrise would arrive slower, every sunset linger longer, as the light bent through layers of heavy air, softening its own brilliance. The sunlight there would also shape time. A day on Kepler-452b lasts much like our own, but the way the light filters through that ancient atmosphere might make it feel different, stretched, deliberate, as though the planet itself were savoring every hour. Morning would creep softly over continents, warming them with gentle persistence. Noon would glow with an almost sacred steadiness. And dusk. Oh, dusk might be endless. A golden quiet where the line between day and night blurs into something dreamlike. For any life that evolved beneath this light, vision itself would be sculpted by its quality. Eyes, if such things exist there, might be tuned to slightly different wavelengths, perceiving shades we cannot name. Plants, if they ever covered its surface, might not be green at all. They might shimmer in deep purples, reds, or metallic blues, pigments adapted to draw energy from a star that burns just a little hotter. Every hue, every reflection, every gleam of moisture on a leaf or a stone would tell the story of adaptation to that precise sunlight. And for us, for human explorers gazing up at that alien sun, it would be a mirror held to our own existence. We take our light for granted, the way it pours across oceans, the way it breathes color into every living thing. But to stand under the light of Kepler-452's sky would be to feel its familiarity pressed against the infinite. It would remind us how fragile our comfort is, how the smallest change in a star's brightness, in a planet's distance, can alter the entire experience of being alive. Light is more than illumination, it is the rhythm of worlds. The photons that leave a star carry not only warmth but time, fragments of history that travel for centuries before touching the soil of another planet. The sunlight that reaches Kepler-452b today began its journey before humanity learned to build telescopes, before we even dreamed of other skies. And when that same light finally reaches us, through the filters of telescopes and the quiet patience of observation, it becomes something more, a connection, a reminder that the warmth we feel here on Earth is part of a larger continuum, that across the galaxy, under different skies, light still falls, life still stirs, and the universe still paints everything in gold. If life ever took hold, it has had billions more years to evolve. Forests of alien green, microbial oceans, or perhaps intelligence, long since risen and gone. Every possibility hums within that distant silence. On Earth, life appeared quickly once the conditions were right, almost as if existence were inevitable. Barely a few 100 million years after our planet cooled, microscopic cells stirred beneath ancient seas, feeding on sunlight and minerals, setting in motion a chain of evolution that would one day look up at the stars and wonder. If Kepler-452b began under similar circumstances, it has had even longer, 1.5 billion more years, to let life unfold in ways we can scarcely imagine. Perhaps it began the same way, simple molecules dancing in the warmth of shallow pools, lightning striking the air, energy weaving chemistry into something self-sustaining. Maybe it grew beneath oceans so deep they never saw light, feeding on heat from volcanic vents. Over time, these forms could have evolved, cells merging, organizing, diversifying, adapting to heavier gravity, to denser air, to the slow brightening of their star. And if evolution continued uninterrupted, what might the planet look like now? Picture vast forests of plants, not green, but deep copper or violet. Leaves evolved to drink in that slightly hotter sunlight. Imagine creatures moving low to the ground, compact and strong under the pull of a heavier world. Some might communicate through vibration, through light, or even through magnetic fields, senses tuned to an environment Earth biology could never survive in. Oceans, if they still remain, could glow at night with bioluminescent tides, chemical light shining beneath a sky tinged amber and gold. Yet there's another, quieter possibility, that life once flourished there and then faded. That civilization rose, thought, built, and dreamed, and then vanished into silence as its sun aged and its oceans withdrew. Maybe they left behind artifacts buried under sediment, traces of metals that do not occur naturally, or isotopes in the soil, that whisper of technology long gone. The signal of their existence could still be traveling through space right now, too faint for us to hear, but still moving outward, like the echo of a long-forgotten song. If we were to stand on that world today, it might feel haunted, not by ghosts, but by time itself. The air might carry memory, the scent of rain that once fell on thriving forests, the distant shimmer of a sea that has nearly vanished. Every gust of wind could be the echo of billions of years of evolution and extinction, the sigh of a planet that lived, adapted, and aged. And yet, even if life never arose there, the potential alone is profound. The chemistry is right, the temperature stable, the orbit steady, all the pieces in place for existence to take a chance. Perhaps it did, perhaps it didn't. The silence of space doesn't mean emptiness, it means patience. The universe speaks softly, in timescales far longer than our lifetimes allow. So we listen, we imagine, we calculate probabilities, trace chemical fingerprints, and send our questions out on radio waves, hoping that somewhere, maybe on Kepler-452b, life awakened long ago, and for a while, beneath that golden sky, knew the warmth of its sun the same way we do ours. An atmosphere is a planet's heartbeat. Detecting its composition, oxygen, methane, carbon dioxide, would tell us whether Kepler-452b still breathes. For now, we listen, waiting for its pulse. A planet without an atmosphere is a planet without a voice. It may exist, solid, ancient, enduring, but it does not speak. Air gives a world presence. It scatters light, shapes weather, carries sound, and holds the chemistry that sustains life. Earth's thin envelope of gas is less than 1/1,000,000th of its total mass. Yet without it, everything we know, the blue of the sky, the warmth of the oceans, the rhythm of the seasons, would vanish. If Kepler-452b ever breathed, that breath would define it more than its size, mass, or orbit ever could. From across 1,400 light-years, however, that breath is impossible to hear directly. The Kepler telescope, sensitive as it was, could only measure dimming light, not the subtle fingerprints of air. But newer instruments, like the James Webb Space Telescope, have begun to read the secrets hidden in starlight. When a planet crosses in front of its star, some of that light filters through its atmosphere. Molecules absorb specific wavelengths, leaving delicate signatures, tiny gaps in the rainbow. From these, scientists can tell what gases are present. Oxygen that hints at photosynthesis, methane that suggests biological activity, or carbon dioxide that speaks of volcanic breath. For Kepler-452b, such a reading remains a dream. Its distance makes the signal almost impossibly faint. Yet models allow us to imagine what its air might hold. If it once mirrored Earth's, it could have begun with nitrogen, oxygen, and water vapor. But as its star brightened, greenhouse gases likely took control. Carbon dioxide could have thickened the air, trapping heat, transforming blue skies into muted amber. Over billions of years, this might have created a feedback loop, where oceans evaporated and water vapor amplified the warming. A slow suffocation, the breath of the world turning shallow. Still, even a thick, hot atmosphere can harbour life. Venus, though harsh, maintains complex chemistry. Jupiter's upper clouds teem with molecules dancing on the edge of possibility. Kepler-452b might have evolved similar complexity, an atmosphere alive with reactions, a chemistry lesson written in vapor and light. There could be equilibrium there, the kind that keeps certain gases balanced only through living processes. Oxygen and methane coexisting, replenished not by random chance, but by metabolism. If we were ever to find such a combination in its spectral lines, it would be nothing less than the planet exhaling proof of life. To imagine this is to imagine intimacy on a cosmic scale. Each molecule of air becomes a word, each gas a note in the melody of existence. The presence of ozone might tell us there's sunlight interacting with organic matter. The hint of water vapor could mean clouds drifting quietly over continents. Even the absence of certain elements, the quiet gaps between signals, would reveal a story of chemistry shaped by time. And so, for now, we listen in silence, waiting for that faint whisper of a world breathing somewhere beyond our reach. One day, a telescope will capture its starlight, spread it into color, and see those missing wavelengths, the fingerprints of air. And when that happens, we will know, finally. Because every living world, from the smallest moon to the grandest gas giant, leaves behind the same truth, a trace of breath in the light. From Kepler's delicate sensors to the eyes of James Webb, each telescope is a time machine, decoding starlight molecule by molecule. Every photon that reaches us is a messenger from centuries past. When we look through a telescope, we are not seeing the present, we are witnessing echoes of the past. The light from Kepler-452b's star began its journey before the first telescopes were ever built, before our species even knew what a galaxy was. Every image, every curve of data, is a message carried across 1,400 years of emptiness, arriving now to whisper what was happening when medieval astronomers first mapped the night sky by hand. The Kepler Space Telescope, launched in 2009, was humanity's first great eye, built for patience. It didn't look for beauty, it looked for patterns. A single patch of sky, fixed and unwavering, filled its vision for nearly a decade. While ground-based telescopes chased comets, galaxies, and supernovae, Kepler stared into one small corner of forever, recording the steady heartbeat of stars. In those rhythms, it found the faint dips of worlds passing in front of their suns. Kepler taught us that discovery sometimes requires stillness, the courage to simply look and wait. When the data from Kepler arrived, it was like listening to a vast cosmic symphony, each note representing a star, each tiny variation a possible world. Astronomers spent years refining the instruments of interpretation, turning light into numbers and numbers into truth. Through this, we learned to detect planets the size of Earth orbiting distant suns, not by sight, but by inference. Every world we've discovered through Kepler was seen not with eyes, but with reason. Now, newer instruments like the James Webb Space Telescope extend that vision into deeper realms. Where Kepler could only sense the dimming of light, Webb can dissect it, breaking starlight into its elemental parts, tracing the fingerprints of molecules in alien atmospheres. Through infrared eyes, it sees the faint glow of warmth from planets too distant to reflect much light at all. Webb's mirrors unfold in the vacuum like petals of a mechanical flower, tuned to catch whispers the universe has been sending for billions of years. Each generation of telescope is a chapter in our species' awakening, the evolution of perception itself. From Galileo's first lens, ground by hand, to the orbiting arrays that now stretch beyond the moon's path, our tools have become extensions of our curiosity. They've turned the night sky from mystery into map, yet each discovery only deepens the mystery further. For every planet found, 10 more await in silence. For every signal captured, countless others drift just beyond the edge of sensitivity, like words spoken too softly to hear. But perhaps the most profound truth our telescopes reveal is not about the stars, but about us. that we are a species compelled to look outward, to build machines that can see where our eyes cannot, to send questions wrapped in metal and glass into the dark, hoping for an answer. Kepler and Webb are not merely instruments of observation, they are embodiments of longing. Every photon that reaches them carries a fraction of the universe's memory. Light that has traveled for ages, untouched, until it strikes a sensor orbiting a tiny blue world. And when that light is decoded into graphs, spectra, and color, it becomes something miraculous. Through our telescopes, the cosmos finally sees itself. Studying Kepler-452b isn't just about finding another Earth. It's about glimpsing what will happen to ours, how oceans vanish, how atmospheres shift, how beauty ages with its star. For billions of years, our planet has existed in a fragile harmony with its sun, close enough to stay warm, distant enough to stay calm. But that balance is temporary. As our star ages, its light will slowly intensify, bathing Earth in increasing heat. It will be a long transformation, so gradual that no single generation will feel it, yet inevitable, written into the physics of starlight itself. And somewhere far away, Kepler-452b may already be living through that story, showing us what lies ahead. To look at Kepler-452b is to look forward in time to see a world like ours 1.5 billion years older. Its star, slightly larger and brighter, gives it just a little more warmth, enough, perhaps, to push it toward change. If it once had oceans, they may now be shallower. If it once had lush continents, they might be slowly fading beneath the encroaching glow of an aging sun. The air, once crisp and breathable, may now hang heavier, thick with greenhouse gases born of a warming world. It's not destruction, it's evolution. The long and gentle aging of a once vibrant planet. This idea fascinates scientists, not because it's tragic, but because it's beautiful. Kepler-452b allows us to see Earth not as fragile, but as part of a larger cycle. Worlds live, they breathe, they change with their stars. What we call climate and decay are simply stages of cosmic maturity. A planet is not a static thing, it's a story written in heat and time, constantly rewriting itself with each new orbit. The evidence of this is everywhere in the data. Computer models show that as a star brightens, the habitable zone drifts outward. Planets once perfectly temperate begin to cross the line into excess. Oceans evaporate. Water vapor fills the skies. Clouds reflect more sunlight, trying to cool the world below. But eventually, the balance tips. The atmosphere becomes thick and hot, trapping more warmth than the surface can bear. It's a process called a runaway greenhouse effect, and one day, our own planet will cross that threshold too. Yet, there's a strange comfort in knowing this. Kepler-452b tells us that nothing in the universe lasts forever, and that's precisely what makes it so precious. Every drop of water, every gust of wind, every living thing exists within a fleeting window of cosmic balance. To witness that is to understand our place in the continuum of time. Perhaps, if we could stand there now, we'd see a world caught between past and future, the last glimmers of oceans shimmering under golden skies, the first signs of transformation whispering in the air. It would not be a world dying, but a world remembering, holding the warmth of its star a little closer, a little longer. And in that reflection, we see ourselves. The same chemistry, the same struggle between light and heat, the same fragility. Kepler-452b is not a warning, but a mirror, showing us that even in the vast, unfeeling sweep of cosmic time, beauty endures right up to the final glow. Models suggest the planet may now be entering a greenhouse phase, a world turning inward, its seas shrinking. Yet, in that slow transformation, there is poetry, the life of a planet growing old gracefully. Kepler-452b is likely living through a long and silent metamorphosis. Its star, burning just a little brighter with every passing epoch, sends more energy toward its companion than it once did. What was once perfect balance has begun to tilt, almost imperceptibly, A few degrees warmer, a little less rainfall, a touch more vapor in the air. Over millions of years, that subtle imbalance changes everything. Oceans begin to evaporate. Clouds gather higher in the sky, their thickness trapping the sunlight that tries to escape. The planet warms itself, layer by layer, until its climate becomes a mirror of its aging sun. This is the slow aging of worlds, not a sudden catastrophe, but a graceful drift towards stillness. It happens so gradually that no single storm or drought would announce it. If there is life there, it would not notice the change from day to day. It would simply adapt, quietly shifting its ways of surviving, migrating toward the poles, burrowing deeper underground, retreating to the last places where rain still falls. The transformation of a planet is not violent, it is patient. Scientists studying Kepler-452b believe it may be in the early stages of what Earth will face one day. The term for it is moist greenhouse, a phase where water vapor, itself a greenhouse gas, begins to dominate the atmosphere. It's a tipping point, a feedback loop where heat creates more vapor, and vapor traps more heat. The air grows thicker, the skies more luminous, the planet brighter from space. It is a world glowing with its own fever. Yet there is a strange beauty in this process. As the seas withdraw, the land beneath them breathes for the first time in eons. New minerals meet the air, reacting, glittering. The color of the world may shift, blues fading to copper, greens to gold. Sunlight scatters differently through the denser air, painting the horizon in deeper ambers. The sunsets could stretch for hours, the light bending across the thickening atmosphere, illuminating the sky with colors no human eye has ever seen. This slow warming is not just a tragedy, it's the natural continuation of creation. Every star, every planet, passes through its own seasons of existence. Kepler-452b's time of gentle habitability may be ending, but that ending gives birth to something new. A different equilibrium, a new kind of beauty. Its rocks and clouds, its chemistry and heat, all find balance in another state of being. If life once thrived there, perhaps it endures still, not as lush forests or vast oceans, but as resilient forms hidden beneath the surface, feeding on minerals and light filtered through dust. On Earth, life has found ways to survive in boiling vents, in frozen deserts, even inside stone. It's not hard to imagine that somewhere beneath Kepler-452b's surface, evolution continues quietly, defying the heat with patience measured in epochs. We often think of aging as decline, but in the universe, aging is transformation, the shifting of energy into new shapes. Kepler-452b, in its slow warming, reminds us that even as light grows harsher, beauty endures. The glow of an older sun, the shimmer of clouds heavy with heat, all of it tells the same story, that time is not an enemy, but an artist, and every world, in its own way, learns to grow old with grace. Infrared spectra may someday reveal traces of methane or ozone, whispers of biology hidden in the wavelengths of alien sunlight. When light travels across the void, it carries more than brightness. It carries fingerprints, patterns etched by every atom and molecule it passes through. To the human eye, these details are invisible, but to our instruments, they tell entire stories. Every planet, every star, every cloud of dust writes its own spectral code in the light it emits or absorbs. And somewhere within that code may lie the faintest hints of life, not in color or image, but in the shape of absence, the places where light has been swallowed by air. For Kepler-452b, this code is still unread. Its distance makes its signal faint, buried within the glow of its parent star. But scientists are patient translators of starlight. When the day comes that our telescopes are powerful enough, they will capture the faint glimmer of its atmosphere as the planet passes in front of its sun. By splitting that light into its rainbow of wavelengths, they'll see dark lines, gaps that reveal which gases absorbed which colors. From those lines, they'll infer the unseen. Oxygen and ozone, when found together, suggest a world where photosynthesis thrives. Methane, in combination with carbon dioxide, hints at life renewing itself through metabolism. Water vapor signals clouds and rainfall, the circulation of a living climate. These gases rarely coexist for long without being replenished by biological activity. If we ever detect such a combination in Kepler-452b's spectra, it will be as though the planet itself has spoken, exhaling a quiet yes into the cosmos. The James Webb Space Telescope has already begun reading these spectral signatures from nearer exoplanets, some only a few dozen light-years away. Through its infrared eyes, it sees the glow of warmth, the breath of chemistry, the hidden fingerprints of molecules. Someday, a successor, even more powerful, perhaps an array orbiting far from Earth's interference, will turn toward Kepler-452 and listen for those same signs. And when it does, each data point, each spectral dip, will carry the potential to change everything we know about our place in the universe. Imagine what it would mean to finally see that pattern, a slight curve in the data that shouldn't exist without life. It wouldn't look dramatic. No photograph, no shimmering ocean or alien forest, just a graph, a subtle line dipping where it shouldn't. Yet within that line would be something profound, proof that we are not alone in chemistry, not alone in breath. The distance between life and lifelessness would shrink, not in miles, but in meaning. Even without confirmation, these searches already carry a kind of quiet reverence. Each spectrum is a prayer written in light, each observation a hope that the universe has repeated itself somewhere else. For now, Kepler-452b remains silent, its message still hidden in wavelengths too faint for us to hear. But the silence is not emptiness, it's anticipation. Somewhere in that distant sunlight, photons are already on their way to us, bearing the signatures of a world's air, its elements, its potential. They've been traveling for centuries, carrying a message we have not yet learned to read. And when we finally do, the universe will feel smaller. Not because we've reached another world, but because, for the first time, one has spoken back. Even if life thrives there, distance swallows its voice. A radio signal would take 1,400 years to reach us, too far for conversation, close enough for imagination. It's a humbling kind of silence, not the absence of sound, but the vast quiet of distance itself. Across those 1,400 light-years, any message from Kepler-452b would still be in transit, moving through the dark like a ghost of thought. If an intelligent civilization had sent a greeting at the dawn of the Renaissance, it would only be arriving here now, encoded in faint radio waves slipping past our antennas, their origin too weak to trace. And if we replied, they wouldn't hear our answer until the 45th century. The cosmos, it seems, is not built for conversation, only for echoes. Astronomers call this the communication horizon, a boundary set not by technology, but by physics itself. Light, for all its speed, becomes a wall between worlds. We can look across it, but we cannot bridge it in a lifetime. The signals we send, pulses of radio, laser flashes, digital whispers, spread outward like ripples on a cosmic pond. But the pond is endless, and time swallows their meaning long before they find a listener. And yet, we keep listening. The SETI projects, Search for Extraterrestrial Intelligence, have turned their ears toward the stars for decades. Sensitive arrays like the Allen telescope listen to entire regions of the sky, passing noise from potential signal, searching for the mathematical regularity that might betray intention. Most of what they find is static, the endless hum of stars and pulsars, the mechanical heartbeat of our own satellites. But once in a while, there's a flicker, a narrowband transmission, a spike in frequency. Something that makes astronomers sit up in quiet hope before reality humbles them again. The universe speaks, but its language is entropy. For all our searching, the silence remains unbroken. Some believe that means we are alone. Others believe it means civilizations are too distant, too brief, or too wise to shout into the dark. Perhaps advanced beings learned what we have only begun to suspect, that the cosmos does not need noise to be full of life. That sometimes, silence is not emptiness, it's coexistence. Imagine though, if the silence isn't silence at all, just timing. Perhaps Kepler-452b has spoken, its message is still on the way. Maybe they sent their first signals when Earth was still young, when our ancestors painted caves and gazed at stars with wonder instead of equations. Those waves would still be traveling now, a faint whisper crossing the centuries. And maybe, someday, one of our instruments will catch it, a pattern too deliberate to ignore, a pulse too structured to be random. Until then, we listen. We build better receivers, larger dishes, smarter algorithms, and we dream. Because in every patch of sky, in every beam of light, there might be someone else listening back, separated not by space, but by time. The great silence is not proof of loneliness. It is the sound of distance between hearts that have not yet met. Every signal we send, every observation we make, is an act of faith. Faith that the universe is not indifferent, just patient. Somewhere, beyond the veil of light, a civilization might be watching us too, hearing our own faint whispers echo through the dark, and wondering, as we do, if they are truly alone. As stars age, they whisper to their worlds in warmer tones. Kepler-452b's sun now glows with a golden patience, the color our own will wear billions of years from now. Every star, like every life, follows a quiet arc of change. Born from clouds of gas and dust, it ignites in brilliance, burns in balance, and then, slowly, softens. Over billions of years, hydrogen at its core fuses into helium, and that delicate equilibrium between gravity and radiation begins to shift. The light grows brighter, the color deepens, and the warmth stretches farther into the surrounding dark. It's not a violent aging, not yet, but a gentle expansion, like the soft deepening of a sunset that refuses to end. Kepler-452 star, at 6 billion years old, is well into that stage of cosmic maturity. It burns with 10% more brightness than our own sun, a subtle but profound difference. That extra radiance spills across the orbit of Kepler-452b, changing the planet's complexion over time. Oceans may have warmed, clouds risen higher, and air grown heavier with vapor. The delicate balance that once made the world temperate may now be slowly tipping toward heat. Yet, to the distant eye, it would be beautiful, a star and its planet aging together, in rhythm, in quiet understanding. This is what astronomers call stellar evolution, though the term hardly captures its grace. Stars do not rush toward change, they drift into it. For every million years that pass, their brightness alters by the faintest degree. But for the worlds that orbit them, that slow brightening means everything. A few percentage points of extra light can turn forests to deserts, rivers to dust, seas to vapor. And still, it happens so gradually that no sunrise feels different from the last. The transformation is invisible, until one day it's complete. Our own sun is following the same path. It, too, will one day glow with that same golden calm, a deeper hue of age, more radiant and tender. When that time comes, Earth will begin to change just as Kepler-452b has. The oceans will retreat, the poles will melt, and our skies will grow thicker with the breath of evaporation. It will not be sudden, it will be slow, graceful, like a heartbeat fading into stillness. Kepler-452's light, traveling across the centuries, is a glimpse of that inevitable future. And yet, there's comfort in that cycle. Stars do not die in sorrow, they pass their energy forward, transforming matter into light, light into warmth, warmth into life. Every green leaf, every ocean current, every breath on Earth exists because a star decided to shine. Kepler-452's star is simply further along that journey, a sun entering its twilight years, glowing with the gentle confidence of age. If we could stand beneath its light, it would not feel like decline. It would feel like serenity. The brightness would be softer, more diffuse. The warmth would feel eternal, the way late afternoon sunlight does when it pools across the ground. There would be a sense that time itself had slowed. that the universe had taken a deep breath and decided to rest for a while. That's the paradox of aging stars. They remind us that endings can be peaceful and that even in the slow dimming of energy, there's beauty. Kepler-452's sun, in all its golden calm, shows us not what we will lose, but what we will become, radiant, enduring, and full of quiet light. Would its sky be blue? Or perhaps a pale green tinted by chemical haze? Under that dome, light would scatter differently, a constant twilight where sunsets last forever. The color of a planet's sky is a story written in light and molecules. On Earth, air molecules scatter short wavelengths, the blues and violets, turning our sky into a serene azure dome. But on another world, even a slight change in air composition, density, or sunlight can paint the heavens in entirely new shades. Kepler-452b's sky could be one of those endless variations, a familiar glow seen through an unfamiliar lens. If its atmosphere is thick with nitrogen and oxygen, its sky might shimmer with the same blue we know, only deeper, more saturated under the warmth of a slightly brighter sun. But if the air is rich with carbon dioxide, methane, or other hydrocarbons, light would scatter differently. The blues could fade into green or even amber. The entire world might exist in a soft, perpetual dusk, not dark, but subdued, the light filtering through a golden veil. Under such a sky, shadows would fall gently and colors would feel warmer, as if every hour were sunset. Imagine standing there. You look up and the horizon blurs into gradients of color, emerald at the base, rose near the zenith, 1,000 tones no human eye has ever seen. Clouds drift higher than ours, stretched thin by gravity's pull, their undersides glowing bronze where they catch the star's aging light. The air hums faintly with dust, scattering brightness in a halo around the sun. Each breath feels heavier, richer, full of unseen chemistry, a reminder that this world, while familiar, belongs to a different chapter of nature's experiment. Even the way light touches the land would be different. On Earth, midday shadows are sharp, but on Kepler-452b, with its thicker atmosphere, light would diffuse more softly. The horizon might glow in all directions at once, giving the illusion of many suns, many sources of brightness. Twilight could linger for hours, the sun never truly gone, just slipping slowly beneath a haze that glows long after daylight ends. If its air once held more water vapor, back when the planet was cooler and wetter, its clouds might have been breathtaking, vast formations rising higher than Himalayan peaks, casting colored rainbows through refracted sunlight. Perhaps even now, remnants of that world remain, mist rising from hidden valleys, refracting the starlight into pale halos at night. Scientists can only speculate, but they know one thing for certain: the color of a planet's sky is the color of its story. It tells of chemistry, of temperature, of time. A bluer sky speaks of clarity and coolness, an amber one of heat and age. Kepler-452b's likely glows in those warmer tones, a world older than ours, illuminated by a sun that has learned patience. To us, it might seem melancholy, a planet bathed in endless sunset, standing at the edge of habitability. But there's peace in that vision too. The slow light, the gentle hues, the way day never fully ends, it all feels like a lullaby, sung by a world growing older with grace. Perhaps that's how the universe comforts its aging planets, by giving them skies that never truly go dark. Every breath, every step there would remind you that you are heavier, more grounded. The air would press closer, sounds lower, heartbeats slower, a planet that teaches stillness. Kepler-452b's mass is estimated to be about 5 times that of Earth. That means gravity there would be stronger, pulling everything a little closer to the surface. A quiet but constant reminder of the planet's strength. You wouldn't float or move with the lightness you know here. Even small movements would require more effort. A jump would rise only half as high. A step would feel deliberate, careful, as though the ground itself was urging you to stay. Yet, there's something deeply grounding about that idea. literally and spiritually. On Earth, we often associate gravity with burden, with weight, but on Kepler-452b, it becomes something else entirely: presence. Every motion would connect you more deeply to the world beneath your feet. The air, denser and richer, would feel tangible, like a soft hand resting against your skin. Your heartbeat would slow, adapting to the pull, syncing with the rhythm of a planet older and steadier than our own. Sound, too, would change. In a heavier, thicker atmosphere, vibrations would travel differently, lower, deeper, more resonant. Your voice would sound unfamiliar, almost musical, as if the world itself were harmonizing with you. The wind would move slowly, rolling across the terrain with weight and intention, carrying with it a soundscape of quiet thunders and deep tones. Even the rain, if it falls, would strike the surface with soft, heavy notes, a melody of density and calm. The landscape would reflect this gravity as well. Mountains would rise lower, their peaks subdued by the planet's pull. Rivers would carve wide, shallow paths through valleys, and trees, if any grow there, would be shorter, sturdier, their trunks built for endurance rather than height. Each feature of the planet would seem to lean inward, shaped by the silent embrace of its gravity. For any life that evolved there, strength would not be a luxury, it would be a necessity. Creatures might move close to the ground, compact and muscular, their bodies efficient against the constant tug. Wings, if they exist, would need immense power to lift. Flight might be rare, perhaps reserved for small, agile organisms gliding briefly between canopies or cliffs. And intelligence, if it arose, might take a slower form, a consciousness rooted in patience rather than haste, in observation rather than movement. Even light would feel different beneath such gravity. The denser atmosphere would bend it slightly, creating mirages and halos that shimmer near the horizon. The world would appear closer, more intimate, the sky pressing down just a little more, as though inviting you to look inward instead of outward. It's a humbling image, a planet that insists on stillness. In a universe obsessed with motion, the spinning of stars, the racing of light, Kepler-452b, would remind us that gravity is not a prison, but a kind of serenity. It's what binds everything together, what gives form to chaos. On such a world, every step would mean something. Every breath would feel earned. You wouldn't take the ground for granted. You'd feel it, holding you close, asking you to slow down and listen. And perhaps, in that heaviness, there would be peace, a deeper awareness that to be pulled by gravity is to belong. Tectonic models suggest that heavier planets forge taller mountains, thicker crusts, longer volcanic lives. Kepler-452b might be a world sculpted by patient fire. Beneath its ancient skies, the bones of Kepler-452b could tell the story of creation and endurance. A planet with 5 times Earth's mass would carry unimaginable pressure within its heart, enough to bend stone like clay, to forge continents that rise not in years, but in ages. Volcanic plumes might have towered for centuries, building mountains layer by layer until they pierced the clouds. Each eruption would not destroy but renew, adding another verse to a planet's slow and fiery song. On Earth, tectonics breathe life into our planet. The drifting of plates recycles minerals, releases heat, and sustains the chemistry that fuels our atmosphere. Without that motion, a world stagnates. Its surface hardens, its air fades, and its seas fall silent. Kepler-452b, with its greater mass, would have a stronger internal furnace. Its mantle would churn with vigor, its crust thicker yet flexible enough to shift. A planet in constant, deliberate motion, not chaotic, but enduring, a slow ballet of rock and fire spanning billions of years. Imagine standing at the base of one of its mountains. It would not resemble the jagged, snow-capped peaks of the Alps or the Andes. These ranges would be titans, vast, ancient, their slopes so broad that a traveler might never notice they were climbing until they realized the air had thinned. The rock would bear the color of age, deep iron reds, weathered golds, and streaks of obsidian black from centuries of volcanic renewal. Each grain of dust beneath your feet would be the ash of 1,000 eruptions, each layer of sediment a page in the planet's autobiography. Rivers might carve through these mountains, but slower than ours, their current thick and patient. Rain would fall heavy, feeding valleys filled with minerals washed from volcanic soil. If life existed, it would find nourishment here, in the chemistry born from heat and stone, the same recipe that once stirred Earth's primordial seas. Perhaps microbial mats cling to the basalt cliffs, feeding on gases escaping through tiny vents, turning poison into possibility. Even now, long after Kepler-452b may have cooled and aged, the remnants of that geologic vigor could remain. Dormant volcanoes waiting beneath crusts of stone, fault lines etched into the surface like scars of time. Each tremor, each mountain shadow would remind us that worlds are not static things. They breathe, they shift, they evolve, carrying the memory of their making in every ridge and valley. And above it all, the planet's higher gravity would sculpt differently. Mountains might rise taller at first, but slump over the eons, their slopes broad and massive, their peaks eroded by patient winds. Landscapes there would feel timeless, soft yet immense, the geography of a being that has lived longer than Earth's continents themselves. To walk among such mountains would be to walk through time. Every stone would hum faintly with heat from the planet's core. Every gust of wind would carry the scent of minerals still forming, still changing. It would be a world that never rushed, a world that built beauty slowly, from the inside out. Kepler-452b may never know silence beneath its surface. Deep down, magma could still move, reshaping the crust in rhythms older than life itself. And if we could listen, truly listen, perhaps we'd hear it, the low heartbeat of a planet that has spent billions of years perfecting the art of endurance. A world sculpted not by chance, but by time, by fire. Future telescopes may soon split its starlight to read its chemistry, a spectral fingerprint revealing whether the planet still holds air, water, and hope. For now, Kepler-452b remains a whisper in the light, a dip in brightness, a rhythm across years. We know it exists, but we do not yet know if it breathes. To find out, scientists have turned to one of the most delicate arts in astronomy, reading the invisible. By studying how starlight changes as it passes through a planet's atmosphere, we can decode the composition of its air, the presence of gases, the temperature of its sky, even the faint signatures of clouds drifting across its horizon. This process, called transmission spectroscopy, is like holding a prism up to the universe. When a planet crosses in front of its star, a small portion of the light filters through the thin layer of gases surrounding it. Molecules within that air absorb specific wavelengths, leaving dark gaps in the spectrum, fingerprints of their existence. Carbon dioxide, water vapor, methane, oxygen, each has its own spectral identity, an unchanging code that no distance can erase. The James Webb Space Telescope has already begun this work for closer worlds, reading the skies of planets orbiting stars tens, even hundreds of light years away. Through its infrared eyes, Webb can sense heat and moisture in alien atmospheres, detect the scattering of haze, and even hint at weather patterns. But for Kepler-452b, 1,400 light-years distant, its faint light remains beyond Webb's reach. To truly know its air, we will need instruments still unborn. Telescopes with mirrors the size of cities, or fleets of satellites acting together as one vast eye. Projects like the LUVOIR, Large UV Optical Infrared Surveyor, and HABEX Habitable Exoplanet Observatory have been proposed to answer that call. They would be capable of separating the planet's glow from its star's brilliance, of finding the thin, ghostly ring of atmosphere that marks a living world. One day, their detectors may show us the first clear signs. A thin band of ozone, the shimmer of water vapor, or the subtle balance of oxygen and carbon that life tends to create. If we ever find those spectral hints on Kepler-452b, the discovery will echo across time. For the first time, we would not only know a distant world exists, we would know it breathes, that it still has air to scatter light, clouds to shape its days, and perhaps oceans that reflect the color of its sun. It would transform the planet from a mathematical possibility into a living presence, a place we could imagine walking beneath, breathing beneath, dreaming beneath. And yet, even the search itself holds beauty. Every photon captured, every spectrum analyzed, is a message from a world that may have long outlived its youth. We may never step foot on Kepler-452b, but in studying its light, we reach across centuries of space, across billions of years of evolution, to touch the edge of its story. Because when we look for atmospheres, we aren't just searching for air, we're searching for meaning, for the delicate proof that somewhere, even now, another world is still alive. Comparing Earth and Kepler-452b is like studying two chapters of the same story, one still being written, one already fading into its epilogue. Both worlds orbit sun-like stars. Both rest in that narrow, miraculous zone where water can remain liquid, where life can take root. But Kepler-452b is older, a sister who has already walked the path we are now upon. In its reflection, we glimpse our own destiny unfolding in slow motion. To study it is to look at time itself, not as a line, but as a loop, a cosmic before and after captured in light. On Earth, we live in what scientists call a middle age of habitability. Our oceans still cool the planet, our atmosphere still shelters life, but Kepler-452b's star, 1.5 billion years ahead, has begun to burn brighter. That extra heat could have shifted its delicate balance, turning forests to dust, seas to vapor, and clouds into the pale veils of a drying world. It's the same path Earth will one day take, a slow transformation written into the physics of every living sun. And yet, within that comparison lies wisdom. By studying Kepler-452b's orbit, its size, and the age of its star, we can predict how long Earth's own habitability might last. Models suggest that in another billion years, our planet too will begin to overheat. The carbon cycle will falter, oceans will retreat, and clouds will rise high into a thickening atmosphere. What we now call climate will become a memory. But in this knowledge, there is no fear, only perspective. Worlds age just as stars do. Their beauty lies in impermanence. Perhaps the greatest lesson from our distant twin is gratitude. Kepler-452b shows us that habitability is fleeting, that balance is a miracle measured not in miles or degrees, but in moments. Right now, Earth stands in a golden equilibrium, warm enough for rain, cool enough for snow, rich enough in air for life to flourish. Kepler-452b reminds us that such perfection doesn't last forever, and that our time within it is precious. Scientists often speak of planetary evolution in terms of physics and chemistry, but there's a deeper layer too, an emotional one. To see another Earth, older and quieter, is to glimpse what our world might look like long after we're gone. It's humbling and strangely peaceful. The knowledge that the universe reuses its designs, that it crafts familiar worlds under unfamiliar suns, means that what we have is not unique, but shared. We belong to a lineage of planets that have lived, changed, and aged before us. If Kepler-452b still holds air, perhaps it smells faintly of dust and metal, of minerals drying beneath a warm sun. If it once had oceans, perhaps the memory of salt still lingers in its rocks. Every echo of its past mirrors a possibility for our own. It is not a warning, but a teacher, showing us what endurance looks like on a cosmic scale. In its silence, Kepler-452b tells us the truth we too often forget, that Earth is a fleeting wonder, suspended in balance, alive in this moment. And like all things touched by light, it will one day fade, but not before leaving its reflection, its lesson, written gently among the stars. If life arose and perished there, it may have left traces, fossilized reefs, organic dust drifting through the atmosphere, molecular ghosts etched in stone. Planets, remember. Not in thoughts or words, but in chemistry, in the slow, deliberate handwriting of time. Every gust of wind, every droplet of rain, every cycle of erosion and renewal leaves a mark, an echo of what once was. On Kepler-452b, that record may still lie hidden beneath layers of rock and dust, preserved in silence. A memory not of civilization, perhaps, but of existence itself, of oceans that once shimmered, of life that once learned to endure. On Earth, memory is everywhere. It lives in coral reefs that grew under ancient suns, in the fossilized shells of creatures long extinct, in the isotopic ratios of air trapped within ice. Even when life disappears, it leaves fingerprints in the minerals and the soil, a pattern too precise to be random, a whisper that life was here. If Kepler-452b once held seas, its sedimentary rocks could cradle the same kind of story, layered minerals bearing the subtle imbalance between oxygen and carbon that only biology creates. Perhaps, deep beneath its crust, there are stones shaped by organisms we will never meet, microscopic builders that laid down calcium or silica as they thrived in alien tides. Over billions of years, those traces would have fossilized, hardened, and endured. If intelligent life ever rose there and faded, their remains might be unrecognizable. Machinery turned to mineral, architecture buried beneath volcanic ash, the legacy of thought erased by the patience of geology. Yet even then, something would linger. Isotopes out of balance, metals arranged too precisely, a chemical alignment that speaks not of nature, but of intention. Astronomers dream of detecting such remnants not by digging, but by listening, reading the chemical breath of the atmosphere for anomalies. Certain molecules, like chlorofluorocarbons or nitrogen oxides, do not occur naturally in large amounts. If we ever detected such compounds on Kepler-452b, suspended in air centuries after their creators were gone, we would be witnessing the afterglow of a civilization. The planet itself would be remembering. Even the dust that drifts above its surface could hold its past. On Mars, our rovers have found ancient organics, faint, stubborn traces that survived despite eons of radiation and erosion. On Kepler-452b, similar dust could swirl endlessly through the sky, glowing faintly in the light of its older sun. Each particle might contain the ghost of a molecule that once lived. Carbon rings fractured by heat, oxygen chains twisted by age. To our instruments, these would appear as subtle patterns in the planet's spectral signature, the faintest suggestion of life's residue. There's a kind of melancholy beauty in that, the idea that a world can carry its history within its air, that even after oceans vanish and forests fade, something remains, a molecular memory suspended between chemistry and story. It's not life, but the memory of life. And in some ways, that's even more haunting. Perhaps that is what the universe does best. It remembers long after the living have gone. The stars recall the atoms of ancient suns, the dust remembers the shape of broken worlds, and light itself carries the echo of moments that no longer exist. Kepler-452b may now be quiet, but silence does not mean forgetfulness. Somewhere beneath its crust, in the weight of its stones and the color of its soil, there may still be proof that something once breathed there, and that, for a brief and precious time, another world shared in the miracle of being alive. At 6 billion years, Kepler-452b stands in planetary midlife, no longer young and volcanic, not yet barren. It exists in that serene middle where life can reflect. There is a quiet grace in a world that has endured this long. The chaos of its birth, the collisions, the molten tides, the roaring volcanism, has long since settled into calm. Its crust has cooled, its mountains have formed their final silhouettes, and its orbit, after countless revolutions, has found a steady rhythm. Kepler-452b may no longer be a world of beginnings, but it has not yet faded into stillness. It exists in a balance, the golden era between creation and decline, where everything breathes in long, patient cycles. On Earth, we find ourselves in a similar moment, Our planet too has reached its middle age, stable, luminous, sustaining life with a calmness that only time can bring. The wild violence of its youth is long past, and the slow fading of its future still distant. In that cosmic middle, life thrives best. There's enough warmth for oceans to flow, enough stability for evolution to take its time. Kepler-452b mirrors this perfection. An elder sibling in the same phase of grace, only a little further along in its journey. Scientists call this planetary equilibrium, the stage when a world's internal heat, magnetic field, and atmosphere exist in harmony. It's a time of balance, when the surface cools to a gentle calm and tectonic motions still quietly renew the crust without tearing it apart. Kepler-452b's larger mass likely extends this phase far longer than Earth's, keeping its interior active and its air intact. It's a cosmic middle age that may last billions more years, a plateau of peace between the fever of youth and the chill of old age. If we could stand there, we might find a sense of timelessness. Days would pass slowly, each one carrying the weight of history but none of the rush of urgency. The air would hum with stillness, not lifeless, but content. Perhaps it's a world where weather drifts more like thought than storm, where wind carries not chaos, but memory. The landscapes, too, would speak of age. Valleys broadened by erosion, mountains softened by patience, rivers tracing paths worn smooth by eternity. And if life still stirs there, it may have reached a stage of reflection, not just survival, but awareness. On Earth, middle age brought complexity, forests, coral reefs, civilizations. Kepler-452b's equivalent moment might host its own symphony of balance, ecosystems that learn to live with the planet rather than against it. Maybe its life, whatever form it takes, has found equilibrium too, creatures in harmony with the slow pulse of a world that has nothing left to prove. This cosmic middle age is where meaning blooms. Youth is for creation and old age for remembrance, but the middle, that fleeting in between, is for consciousness. It's the span of time when a world can look inward and understand itself. So perhaps, if we ever could look upon Kepler-452b, we would not find a world in decline, but one in deep reflection. A planet breathing slowly beneath a golden sun, holding steady in the quiet center of its own story. Not too young, not yet fading, simply alive in the most peaceful way a world can be. Its orbit is nearly circular, a rare gift in the cosmos. That steadiness may have given evolution the calm centuries it needs to dream itself awake. In the grand architecture of the universe, stability is an exception, not the rule. Most planets follow orbits that stretch and tilt, pulling them through cycles of heat and cold, chaos and calm. Seasons on such worlds can be violent, centuries of ice followed by eras of fire. But Kepler-452b moves differently. Its path around its star is nearly perfect, a slow, even dance that keeps it bathed in consistent light. That precision, that cosmic symmetry, may have been the very reason life ever had a chance to begin there. A circular orbit means rhythm, predictable, patient, forgiving. It means the planet never strays too far into the chill of distance or too close to the furnace of its sun. Day after day, century after century, it receives just enough warmth to keep water liquid and chemistry alive. On Earth, the same gift allowed the fragile miracle of balance to unfold. Oceans to form, continents to breathe, ecosystems to find their footing. Kepler-452b, too, may have benefited from this harmony, a cosmic geometry drawn so precisely that even time itself seems to move more gently around it. If life exists there, it has had the luxury of consistency. Evolution flourishes not in turmoil, but in patience, in the quiet repetition of days, in cycles that last long enough for change to mean something. With each orbit identical to the last, Kepler-452b could have nurtured life with an unbroken rhythm, allowing organisms to adapt not to catastrophe, but to subtlety. The same sunrise, the same length of shadow, the same familiar warmth year after year, conditions so stable that intelligence itself might emerge not from struggle, but from stillness. Such perfection is fragile. Even a small perturbation, the pull of a passing star, the drift of a distant planet, could nudge the orbit, breaking that balance. But for billions of years, Kepler-452b's star system has remained remarkably quiet. No giant neighbours tugging at its path, no debris belts to scatter comets inward, just a single sun, a patient planet, and the slow waltz between them. It's the kind of peace that the cosmos rarely allows, a rare pocket of order in an ocean of chaos. This architectural serenity tells us something profound about creation. The universe is not built for balance, yet it allows it, fleetingly, beautifully. And within that balance, life finds a foothold. Kepler-452b's near-perfect orbit may be the difference between a barren rock and a breathing world, between silence and consciousness. If we could stand there, we might feel that steadiness in everything, in the way the sun rises at almost the same point every day, in how the temperature drifts but never shocks, in the patience of the wind. Even the shadows would feel predictable, like the pulse of a planet that has never known chaos. It would be a place where time feels circular, each day folding seamlessly into the next, not monotonous, but eternal. Stability, in the cosmic sense, is not stillness. It's what allows molecules to meet, atoms to bond, and ideas, biological or otherwise, to evolve. Kepler-452b's calm orbit is not just a celestial statistic, it's a sanctuary. And maybe that's the real miracle of this distant world. Not that it exists, but that it endures. That in a universe defined by motion, explosion, and change, something can remain steady long enough for life, and maybe even thought, to take a breath, look up at the sky, and wonder. Models place its average temperature near 75 degrees Fahrenheit, a global springtime. But as its star brightens, warmth may creep across continents like a slow dawn that never ends. There's something profoundly peaceful about that number, 75 degrees Fahrenheit. It's the kind of temperature where life flourishes most easily, where water moves freely and air feels soft upon the skin. On Earth, it's the warmth of gardens in bloom, of oceans breathing mist into the air. For Kepler-452b, that same climate would mean a planet in perfect equilibrium, a gentle balance between the chill of space and the fire of its star. For now, at least, it might still be a world wrapped in eternal spring. But perfection in the cosmos is always temporary. Stars are restless alchemists, burning through their fuel, changing subtly but relentlessly. Kepler-452's star, older and more luminous than our Sun, has already begun to shift its tone, radiating just a little more energy each million years. To a world like Kepler-452b, such change is glacial, almost imperceptible, yet unstoppable. With each passing eon, warmth seeps deeper into its air and soil. Lakes shrink at their edges, glaciers retreat to higher altitudes, and rain falls a little less often. The planet brightens, not through light, but through heat. Scientists believe this slow warming may resemble the Earth's distant future. As our own sun grows older, its output will increase too, causing similar ripples in our climate. What feels stable now, our seasons, our oceans, our clouds, will gradually shift toward intensity. Kepler-452b may already be showing us what that future looks like. A world not destroyed, but changed, adapting quietly to an evolving sun. Imagine walking across its surface. The air would feel heavier than Earth's, but temperate, perhaps humid, fragrant with minerals and heat. The sunlight would seem familiar but more golden, richer, as though every photon carried a hint of age. Vegetation, if it exists, might glow in deeper hues, burnt amber, bronze, or violet. Pigments evolved to manage the star's stronger light. Streams would wind through valleys of slow warmth, their surfaces shimmering beneath skies painted with faint, endless clouds. Even the nights might hold heat, lingering long after the sun had set, as though the planet itself refused to let go of its star's touch. It would be a world where days blur together, the seasons indistinguishable, not through monotony, but through constancy. Every sunrise would carry the same soft warmth, every evening the same lingering glow. This temperature, this delicate global spring, is more than comfort. It's the heartbeat of habitability. Too cold, and chemistry freezes; too hot, and it dissolves. But within this narrow window, life not only survives, it flourishes. Oceans circulate nutrients, storms balance energy, and ecosystems find stability. Kepler-452b, sitting right in that gentle zone, may have experienced billions of years of such calm. But as the dawn of heat spreads, slow, inevitable, that balance will begin to tip. The seas might be receding, the air thickening, the planet shifting from spring into an endless summer. It's a transformation that doesn't destroy, but transforms. The aging of a world that once was young. And yet, even as its temperature climbs, the poetry of Kepler-452b remains. For somewhere in that slow, creeping warmth lies the story of life's endurance. The ability to adapt, to evolve, to find comfort even as the sun grows fierce. It's a reminder, both cosmic and intimate, that balance is never permanent, but beauty can exist even as it changes. A global springtime becoming a golden summer, a planet not ending, but growing old beneath its brightening sky. Scientists now look for the faintest mix of gases: oxygen with methane, carbon dioxide with water vapor, patterns that can't exist without the hand of biology. This is the frontier of discovery, not in distant landscapes or uncharted oceans, but in light itself. Every world we've found beyond our own is little more than a flicker in the darkness, a curve in a graph. Yet within those flickers, entire histories may hide. To read them, scientists search for biosignatures, chemical patterns so unlikely, so delicately balanced, that nature alone struggles to explain them. They are the fingerprints of life, hidden in the breath of alien worlds. For decades, the search for life was a question of distance and temperature, the habitable zone. But now, the hunt has become more intimate. We no longer ask merely if a planet could host life. We ask whether we can hear it, in the chemistry of its air, in the whisper of its atmosphere as it bends the light of its star. To find those answers, astronomers have turned to spectroscopy, using instruments capable of breaking starlight into rainbows of meaning. Every molecule leaves its own shadow on that light, an imprint of what the planet is exhaling. On Earth, our own spectrum glows with imbalance. Oxygen and methane coexist in quantities that should cancel each other out, yet they persist, replenished by photosynthesis, by the breath of forests, oceans, and animals. It's this imbalance that betrays our presence to anyone watching from afar. To detect such a signal on Kepler-452b would be like catching a heartbeat through the noise of a storm, faint, fragile, but unmistakably alive. The James Webb Space Telescope has already begun its work, analyzing closer exoplanets for such chemical songs. But Kepler-452b is distant, its light too faint for Webb's reach. Future observatories, perhaps the size of cities or built in orbit around the Moon, will take up the challenge. These next-generation instruments will not just see the planet, but listen to it, passing every photon for signs of balance, contradiction, and life. Even a single detection, a wisp of methane paired with oxygen, a spike of carbon dioxide laced with water vapor, would send ripples through history. Because such pairings are fragile, they require something dynamic, something alive, to maintain them. Without biology, methane burns away. Without photosynthesis, oxygen vanishes. To find them together is to find the fingerprint of metabolism, the exhalation of life. But this search is not merely scientific. It's deeply human. Every telescope pointed toward Kepler-452b carries more than instruments. It carries hope. The hope that the loneliness of space is an illusion. The hope that somewhere, beneath a sky of unfamiliar color, something is breathing, thinking, perhaps even looking back. And yet, there's humility in the search too, because for all our sophistication, we are still learning to read the simplest signals of existence. And the difference between a living world and a dead one may be nothing more than a trace of gas, a fractional dip in starlight, a barely measurable anomaly in the void. That's the beauty of the biosignature hunt. It turns silence into language. It asks us to listen not for words, but for patterns, for harmony in the chemistry of distant skies. And one day, when we finally detect that perfect, impossible combination, when we see oxygen and methane dancing together across light years, it will not just mean we've found life, it will mean we've found company. Seen from afar, Earth and Kepler-452b would look almost identical, two blue marbles adrift in black. But one might already be fading to brown. From a distance, the universe paints all living worlds with the same brush: oceans of blue, clouds of white, continents etched in earthy tones. To the eye of a distant observer, Earth would appear serene, a fragile sphere of water and light circling a modest star. Kepler-452b, orbiting a sun so much like ours, would seem its twin, the same shimmer of reflected oceans, the same pale halo of atmosphere. But light can be deceptive. The color of a planet tells a story. And sometimes, it tells us when that story is changing. On Earth, the blue comes from water, from oceans that absorb red light and scatter the rest. But as a world warms and its seas shrink, that color begins to shift. Dust replaces mist, rock replaces wave. The reflective clouds that once brightened its face begin to thin. Slowly, the blue fades to gold, then to copper, then to the muted brown of bare continents under a hotter sun. It's the same transformation Mars once endured, and Venus before it, a planetary aging that begins softly, beautifully, before it turns final. If Kepler-452b still holds oceans, they might be shallower now, glimmering mirrors tucked between desert plains, evaporating a little more each millennium. Its clouds, fewer but denser, might shimmer like molten glass in the light of its older sun. To a telescope, the planet's albedo, its reflectivity, would betray these changes. Less blue, more ochre, a slow transition from the color of water to the color of memory. Astronomers call this the pale reflection paradox. Worlds that once looked alive continue to shine long after they've gone silent. Even after oceans vanish, the remaining minerals and atmospheric haze can mimic the spectral signatures of life. A dead world can still look living, a ghost caught in the light of its past. Kepler-452b might be one of these haunting reflections, still glowing blue in the language of photons, but already quiet beneath the surface. It's humbling to think that somewhere, an observer looking back at Earth might see the same illusion. From their perspective, our planet's light might still seem perfect. The color of oceans, the shimmer of clouds, even as climate, life, and history unfold beneath that sheen. From space, all worlds appear eternal. Up close, they are as fragile as breath. And yet, there's beauty in that shared reflection. Kepler-452b, even if fading, mirrors what we are and what we will become. Two planets, separated by centuries of light, caught at different points in the same story. One still full of sound, the other slipping into silence. But both testaments to the same truth, that the universe, for all its vastness, loves to repeat itself. Perhaps that's the poetry of it all, that even as light fades, it carries the memory of what once was. The blue of Kepler-452b may already belong to the past, but its reflection still crosses the void, a soft echo of oceans long gone. And when that light reaches us, centuries later, it whispers a quiet message that beauty endures, even when it's only a memory written in color. SETI telescopes have pointed toward that star many times, hoping for a deliberate whisper. So far, silence. But silence, too, is a kind of message. Across the quiet plains of deserts and mountaintops, giant radio dishes tilt toward the heavens, listening. They wait for patterns, not noise, intention, not chance. Somewhere in the stream of cosmic static, there might exist a signal, a deliberate rhythm, a beacon built not by nature, but by mind. Kepler-452, with its sun-like star and Earth-like planet, has been one of the most tempting targets of all. Again and again, scientists have turned their antennas toward it, hoping that, across the centuries of light between us, something or someone might be calling back. What they find instead is the background hum of the universe, pulsars ticking, quasars flaring, the constant hiss of creation itself, and buried within that infinite static, perhaps faint beyond measure, the unknown voices of distant stars. But no message from Kepler-452b. Just silence, the deep, infinite kind that humbles even the most patient listener. Yet silence does not always mean absence. In science, as in life, sometimes what isn't heard can say as much as what is. Perhaps Kepler-452b is home to no one, a world of clouds and stone. Or perhaps it once was, long ago, before its sun grew too bright and its oceans too thin. But there's another possibility, that a civilization lived, thought, and chose quiet. That it looked into the same darkness we do and decided that some messages are better left unspoken. SETI researchers often talk about the cosmic haystack, the nearly impossible task of finding a single needle of intelligence in a galaxy of noise. The haystack isn't just vast in space, it's vast in time. A signal sent from Kepler-452b 1,400 years ago would only reach us now. If we replied today, our answer wouldn't arrive until the year 3,425. In that span, entire civilizations could rise, fall, and vanish before a single word is exchanged. Communication across such gulfs becomes something more like archaeology, uncovering echoes from those who may no longer exist. And still, we listen. Because listening is an act of hope. Each moment of silence is another reminder that we can listen, that our technology, our patience, and our curiosity have stretched beyond our own atmosphere into the great dark sea. We may never hear a voice, but the act itself, the leaning of an antenna toward possibility, is its own kind of prayer. Maybe the silence from Kepler-452b isn't emptiness. Maybe it's equilibrium, a civilization that reached understanding, then quieted itself to watch the stars. Or maybe it's a message written not in words, but in restraint. We were here, once, and now we rest. Either way, the quiet is profound. When our receivers fall still and the static fades, we're left with something larger than sound. The awareness of distance, of time, of the sheer scale of the question we're asking. And so we keep listening. Not because we expect an answer, but because the act of asking connects us to them, to the cosmos, to ourselves. In that silence between stars, we hear the faintest echo of our own longing and realize that even unanswered, the question is worth asking. Every habitable planet is temporary. As stars age, they erase what they once nurtured. Kepler-452b reminds us that paradise is never permanent. It is one of the universe's most elegant cruelties. The very stars that give life must one day take it away. Their warmth awakens worlds, stirs oceans, drives the engines of weather and growth. But their constancy is an illusion. For a while, the balance holds. Kepler-452b exists in that fragile middle, old enough to remember gentler days, yet still far from the final silence. Its sun, once steady and calm, now burns with the soft brightness of age. That extra light warms the planet beyond comfort, drawing moisture from its seas, thickening its air. The process is slow, too slow for any eye to see, but relentless. Over millions of years, the oceans shrink, the clouds thin, and the landscape transforms. The world that once may have sung with life begins to grow quiet. This is not decay, but transformation, the cosmic cycle written into the DNA of existence. Stars consume themselves in beauty, planets adapt, endure, and fade. Even the most perfect worlds, balanced so delicately between heat and cold, must someday step across that invisible boundary between fertile and barren. Venus once may have known oceans, Mars once breathed thin air. Earth, too, will join them in time. Kepler-452b only reminds us of where we are on that path. And yet, there is something profoundly gentle in that inevitability. When we speak of the fate of all worlds, we often imagine destruction, fire, collapse, extinction. But nature does not destroy, it transforms. Oceans become vapor, rocks become dust. Molecules once bound in living things drift outward, to be reborn in other stars, other systems, other lives. The death of one world becomes the seed of another. Kepler-452b, in its slow warming, is not a tragedy, it's a teacher. It shows us what happens when time is allowed to play its full melody. It reminds us that permanence is not the goal of creation, continuity is. That every ending carries the potential for new beginnings, even if they lie beyond our sight. If we could stand there and watch the centuries pass, we might see oceans retreat into vapor, mountains redden under a hotter sky, and rivers fade into memory. But the beauty would remain, not gone, merely changed. It would be a world remembering its youth, letting go with grace. Perhaps this is the truest lesson Kepler-452b offers, that no paradise lasts forever, and that's what makes it sacred. Every living world exists within a narrow window, a pause between chaos and silence. We are fortunate enough to be living within that pause right now, on our own blue planet still thriving under a gentle sun. When we look at Kepler-452b, we aren't just seeing another planet. We're seeing our own reflection in the future, the story of how light gives and how it takes away. And maybe, knowing that all worlds are temporary, we can learn to love ours more fiercely, not because it will last forever, but because it won't. The photons reaching us now left before humans built telescopes. To study them is to converse with the past and to foresee our own far-off tomorrow. Light is memory, moving through darkness. Every photon that touches our instruments from Kepler-452b's star began its journey 14 centuries ago, long before telescopes, before electricity, before we even knew what a planet truly was. Those tiny messengers have been crossing the void ever since, unbroken, unbent, each one carrying a story from a time when humanity was still mapping its own skies with myth. And now, after 1,400 years, they arrive, and we turn them into knowledge. It's a strange form of conversation, one conducted across eons. We ask questions with technology. The universe answers with light. But by the time the answer reaches us, the moment we asked about is already ancient history. When we study Kepler-452b, we're not seeing it as it is, but as it was, a fossilized moment in time, frozen in photons. The planet we imagine now could already be gone, its oceans boiled away, its air thinned to silence. Or perhaps it has changed in subtler ways, continuing its slow drift toward heat and stillness. We won't know for another 1,400 years. That's the poetry of astronomy. Everything we see is the past, and yet, through that past, we glimpse the future. The light from Kepler-452b's star, slightly brighter than our own, is the mirror of our destiny. To look upon it is to see the story that awaits Earth. Oceans shrinking, clouds scattering, life adapting or fading. We study its photons not just to understand it, but to understand ourselves. Every spectrum, every graph, every flicker of light is a record of patience. The universe keeps no diaries, but its light is eternal documentation, traveling endlessly, never forgetting. Photons that once struck the surface of Kepler-452b might now be painting faint signatures onto our sensors, revealing temperature, chemical composition, perhaps even weather. They are fragments of a long finished day on another world, a sunset no one watched, a glimmer of oceans that may no longer exist. And yet, those fragments are enough to spark wonder, because through them we can trace time's symmetry, the way the future of one world echoes the past of another. Kepler-452b shows us that every planet's story is written in layers of light, birth, balance, decline. Ours is simply the next page in the same cosmic book. When we gaze at that distant star, we are reading a story whose ending we already know, but whose beauty lies in its unfolding. Every photon we catch is both a relic and a prophecy, a reminder that all things, even worlds, shine brightest just before they change. Someday, light from Earth will make the same journey outward, carrying our reflection to other eyes, perhaps to another civilization, far in the future, who will study our photons and wonder who we were. They will see our oceans, our clouds, our thin blue atmosphere, just as we now see Kepler-452b. To them, we will be the past, and perhaps their future. In that way, light connects us all. It erases isolation, blurs the boundaries of time, and turns observation into communion. When we look toward Kepler-452b, we are not only watching the past, we are writing our own tomorrow into the fabric of the cosmos. One day, our instruments will resolve its oceans, its continents, perhaps its clouds, and will look upon it not as strangers, but as distant relatives separated by time. For now, Kepler-452b exists for us only as light and numbers, a faint, rhythmic dimming in a distant star. We've mapped its orbit, measured its gravity, modeled its climate, but we've never truly seen it. Yet the story of science is the story of patience, and patience, in the cosmos, always pays off. The same way our ancestors once turned the faint blur of Jupiter's moons into a revelation, one day our descendants will turn Kepler-452b's flicker into a face. It may happen centuries from now, when telescopes orbit far beyond Earth, vast mirror arrays floating in deep space, linking together into lenses as large as cities. They will gather light atom by atom, focusing it with such precision that distance will no longer mean invisibility. And then, for the first time, we'll see it, a small world suspended in sunlight, pale and luminous against the void. Maybe we'll see oceans glinting beneath an amber sky, the shimmer of continents painted in hues no human eye has ever witnessed. Or maybe we'll see a quieter world, drier, older, its colors softened by dust and time. But either way, it will be real. Not just a graph, not just a probability, but a place, solid, tangible, alive in its own way. That first image will be more than a discovery. It will be a reunion. Because in Kepler-452b's reflection, we'll see the shape of our own story, Earth's past and Earth's future held together in one frame of light. Its mountains will echo our own. Its clouds will remind us of home. And for a fleeting moment, across 14 centuries of light, we'll understand that this planet is not alien, but ancestral. A sibling world born of the same physics, the same chemistry, the same cosmic desire to create beauty out of chaos. Scientists will study its weather patterns, its colors, its brightness. But beyond the data, there will be emotion, the kind that defies graphs and measurements. Because to finally see another Earth is to be reminded that we are not an accident, that the recipe for life, for oceans and clouds and thought, has been written more than once, that the universe, vast as it is, chooses to rhyme. Perhaps, in that moment, humanity will fall silent. Our telescopes, our machines, our networks, all tuned to a single image of another world, shining softly in the darkness. We will realize that this is what we've been searching for all along. Not aliens, not proof, but connection. The recognition that somewhere else, under another sun, a planet like ours, has lived, changed, and endured. And maybe, as that image spreads across our screens and minds, someone will whisper what we'll all be thinking, that it feels like looking into a mirror held across time. That we are, at last, face to face, with the universe's other dream of home. In searching for life on Kepler-452b, we're really searching for ourselves, for proof that life is not an accident, but the universe recognizing its own reflection. Every telescope, every signal, every faint curve of light we study is part of that deeper question. Not, is there life out there, but what does our own life mean in all of this? The search for other worlds has always been a mirror held up to our own. When we look toward Kepler-452b, we're not just looking outward into space, we're looking inward into our own origins, our own fragility, our own longing to belong to something greater than this small blue world. Kepler-452b may never answer us. It may remain a world forever out of reach, orbiting its golden star in eternal silence. But in chasing its signal, in studying its light, we have already learned something profound, that life, any life, is not just chemistry or chance. It's the cosmos awakening to itself. Every atom in our bodies, every photon that touches our skin, was forged in the same furnaces that burn in stars like Kepler-452's. To seek other life is to seek the parts of ourselves that have drifted outward into the dark, waiting to be seen again. Perhaps one day we will find evidence, a wisp of oxygen paired with methane, the shimmer of oceans beneath alien clouds, or even the deliberate pulse of an artificial signal. And when that day comes, the discovery will not make us smaller, it will make us infinite. Because we will know that consciousness, curiosity, and beauty are not unique to us. They are part of the universe's design. But even if we never find that proof, the search itself is its own kind of answer. It tells us who we are, creatures made of dust and wonder, reaching outward, not because we are lost, but because we are connected. Every observation, every night, spent staring into the dark, every data point, every dream, all of it is the universe trying to remember itself. Kepler-452b may be far beyond our grasp, but it has already given us something priceless: perspective. It reminds us that we are not at the center of everything, but part of everything, that we are temporary, yet luminous, that our smallness is not a flaw, but a miracle. So as we listen for whispers across light years, as we chase faint signals through oceans of static, we should remember this: the quiet truth of the cosmos is that we were never alone. We have always been pieces of the same vast, breathing whole, reflections of the same starlight, asking the same question into the dark. And maybe that is what Kepler-452b truly offers us. Not confirmation, not contact, but calm. The peace of knowing that to exist, to wonder, to look up at all, is already to be part of something eternal. Somewhere between the starlight and the silence, we carried a question and returned with a mirror. Kepler-452b taught us about time, possibility, and the gentle ache of cosmic kinship. We traced photons older than our language, imagined oceans that kept their secrets for billions of years, and listened for the faint chemistry of breath on an alien shore. Whether that world holds forests, microbes, or only memory, it reminds us that life is a patient, generous thing that blooms wherever conditions allow. Now, breathe in slowly. Imagine that warm, distant light spilling across an unfamiliar sea, and feel the small, steady truth of being part of this vast story. Rest here, soft, curious, and safe. Good night.